15th term. Now, all geometric sequence has common ratio. Therefore, 1, 3, 9 has also a common ratio. We can use 3 and 1 to find the common ratio. Divide 3 by 1. 3 divided by 1 equals R equals 3, which is the common ratio. Or you may use 9 and 3. 9 divided by 3 is also 3, the common ratio. From the given, our first term, or a sub 1, equals 1. And the value of n will be 15 because we are going to find the 15th term. We can find the 15th term using the formula of geometric sequence. The formula in finding the n term, a sub n equals a sub 1 times r raised to n minus 1 times raised to a sub n equals a sub 1 times r raised to n minus 1. Substitute a sub n equals 15, so we have a sub 15 equals a sub 1 equals 1, so we have 1, r is 3, and then n is 15 minus 1. Simplify it further, we have a sub 15 equals 1 times 3 raised to 15, because 15 minus 1 is 15. Now, a sub 15 is equivalent to 1 times 3 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 times 3. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 here. 14 threes. So we are multiplying 3 14 times because the exponent is 14. Using the calculator, the 15th term is 4,782,969. Again, the 15th term is 4,782,969. If we will continue or complete the sequence, that is 1, 3, 9, and then next to 9 is 27, 81, so forth and so on. The 50th term is 4,782,969. Given 486 and 2. We will find 4 geometric means, meaning we will insert 4 missing terms between 486 and 2. Our n here is 6. 486 will be the first term. The second term will be the first geometric mean. The third term is the second geometric mean. The fourth term will be the third geometric mean. And the fifth term is the fourth geometric mean. 2 will be our sixth terms, or the last term. Again, the first term is 486, and a sub n equals 2, which is the last term. We will solve for r using the formula of geometric sequence to get the n term equals the first term times the ratio raised to n minus 1. From the given, our last term is 2. Our first term is 486, so substitute 2 to a sub n. 486 will serve as our a sub 1. Our 6 will be our n minus 1, that will be 5. So 2 equals 486 times r raised to 5, because 6 minus 1 equals 5. To solve for r, we will divide both sides of the equation by 486. So 2 divided by 486 equals 486 divided by 486 times r raised to 5. 486 divided by 486 equals 1. So therefore, we have 2 over 486 equals r raised to 5. 486 can be written as 2 times 243. 2 times 243 equals 486. Now, 2 divided by 2 equals 1. Therefore, we can write it as 1 over 243 equals r raised to 5. Now, simplify it further by extracting the fifth root of 1 over 243 equals the fifth root of r raised to 5. The fifth root of r raised to 5 equals equals r. So, r then is the fifth root of 1, which is 1, and the fifth root of 243, which is 3. So, our common ratio is 1/3. 3 because we have 3 times 3, 3 times 3 equals 9, times 3, 27, times 3, 81, 81 times 3 is 243. The fifth root of 243 is 3. So our common ratio is 1/3. Our first geometric mean, therefore, is 162. How do you get 162? That is 486 times 1/3, or 486 times 1 divided by 3. 162, the first missing term or the first geometric mean. The second geometric mean is 54. To get 54, you just multiply 162 times the common ratio, which is 1/3. That is 162 times 1 divided by 3, or 162 divided by 3, that is 54. And then 54 times 1/3, or 54 divided by 3 is 18. And then 18 times 1/3, or 18 times 1 divided by 3, that is 6, or 18 divided by 3 equals 6. The last term is 2 because 6 times 1/3, or 6 times 1 equals 6 divided by 3 equals 2. Therefore, the four geometric means are 162, 54, 18, and 6. To find the sum of the first 5 terms, we will consider only the terms from 3, 6, 12, 24, and 48. And we will use the formula S sub n equals the first term times the quantity of 1 minus r raised to n all over 1 minus r, or we will use S sub n equals the first term times the quantity of 1 minus r raised to n all over 1 minus r. So the given in this situation are 3, 6, 12, 24, 48, 96, so forth and so on. It is finite because we will find only the sum of the first 5 terms. So we will consider only 3, 6, 12, 24, and 48, the 5 terms. So our first term will be 3, our n will be 5, and our ratio is obtained by using 6 and 3, or 6 divided by 3, or we can also use 12 divided by 6, or we can use 24 divided by 12. All of them is equal to 2. 6 divided by 3 equals 2, 12 divided by 6 equals 2, 24 divided by 12 equals 2. That would be our common ratio. Substitute it to the formula. Again, our n will be 5, the number of terms, because we are asked to find the sum of the first 5 terms. So n is 5. Our first term is 3. And then our ratio, common ratio is 2 raised to 5. Our n divided by 1 minus 2, which is our r. Or you can do it in different ways, like 3 times 1 minus 2 raised to 5 all over 1 minus 2. Simplify it. We have 2 raised to 5 will be 2 times 2 times 2 times 2 times 2. We will multiply 2 by itself 5 times because of the exponent 5. 2 times 2 is 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that is why we have 32. And then 1 minus 32 is negative 31 all over negative 1. 31 divided by negative 31 divided by negative 1 is positive 31 times 3 will give us 93. The sum of the first 5 terms is 93. There is another way of doing it, a simpler way of doing this, and it is presented in your module.
For infinite geometric sequence, before we will get the sum, we will examine first the ratio, because the sum for infinite geometric sequence exists only if the ratio is greater than negative 1 or less than 1. And in infinite geometric sequence, the sum exists only if the ratio is greater than negative 1 but less than 1. So in our two examples, we will consider first or examine first the value of r before we will find their sum. Okay, for number 1, the ratio is taken from 1/4 divided by 1/2, or you may use 1/8 divided by 1/4 to get the ratio, common ratio. 1/4 divided by 1/2 is 1/4 times the reciprocal of 1/2, which is 2 over 1. Or if we will use 1/8 divided by 1/4, that is 1/8 times the reciprocal of 1/4, which is 4 over 1. 4 here can be written as 2 times 2. 2 times 2. That is 4. So that we can divide 2 divided by 2. The answer will be 1/2 our r. Or if we will use 1/8 times 4 over 1, 8 can be written as 4 times 2. So that we can divide 4 divided by 2 and simplify it, we get 1 times 1 is 1 over 2. R is 1. Now if we will verify or examine our ratio is less than 1 but greater than negative 1. Therefore, we can solve for the sum of number 1. Now how about for number 2? To solve for the common ratio, we will divide 9 divided by 3, which is equal to 3. Or we can use 27 divided by 9, which is also equal to 3. So therefore, or you can use 81 divided by 27, which is also 3. Therefore, the common ratio for number 2 is 3. Now, in infinite geometric sequence, the sum exists only if r, the ratio, is less than 1 but greater than negative 1. In number 2, our r is 3. Now, r here is greater than 1. Therefore, for number 2, the sum does not exist. Therefore, we will only solve the sum for number 1, because in number 2, the sum,
And forget, in finding the sum of the geometric sequence, we should always examine the ratio. The common ratio should be less than 1 but greater than negative 1. And also the formula finding for sum of infinite geometric sequence is equal to the first term divided by 1 minus 1. Going back to our first example of the infinite geometric sequence 1/2, 1/4, 1/8, and 1/16 to infinity know also that the ratio of this geometric sequence is 1/2. Now, since 1/2 is less than 1, but greater than -1, we can find the sum of this infinite geometric sequence. Using the formula, we will substitute. Our first term is 1/2, our ratio is 1/2. So A sub 1 is 1/2, R is 1. Simplify it further, we have 1 minus 1/2 can be written as 2 over 2 minus 1/2. 2 divided by 2 is 1. So we are rewriting 1, 2, 2 divided by 2. Simplify it further, we have 1/2 over 1/2 because 2 minus 1 is 1. Copy the denominator 2. And then simplifying it further, we have 1/2 times 2 over 1. 1/2 times 2 over 1 is equal to 1 times 2, which is 2, and 2 times 1, which is 2. 2 divided by 2 equals 1. Therefore, the sum of 1/2, 1/4, plus 1/8, plus 1 over 16 up to infinity is equal to 1.